Hello, everyone. My name is Josh Furman from Meyer Tech Support. We're excited for you to be here. We're excited to talk about Spacemap Go today. The theme of today's roundtable is what is Spacemap Go? We want to first teach you about Spacemap Go, run through some different various things that we are training on, and then the rest of the time we'll talk and collaborate. With me throughout these roundtables, I'll have a series of panelists. The next part of our housekeeping we want to talk about is the Spacemap Go help website. And you can get to the Spacemap Go help website from the Spacemap Go application, but you can also go to spacemap-go-help.meyersound.com. And this website is basically the operating instructions for Spacemap Go. We are populating it with more information, how to do things, and this should be your first line of defense if you have a question about Spacemap Go, how to integrate it, how to connect it, how to program third-party devices. There's so much information on this, and Steve and the product management team have done a very good job with it. And then, of course, you might have a feature request that you would want, or occasionally with software you find bugs. So we recommend that you go to the meyersound.com/contact page. And if you have a feature request or bug report, fill out a software support form. But if you just have a general question, you're confused about something or need to know something, fill out a technical support form. So there's two different forms, fill them out, but your first line of defense is the help website. Chances are your question will be answered there. Last week, we released Spacemap Go, and we released a new video giving you a general application overview. With this roundtable, we're probably not going to get to the general application overview, but have no fear. On our Thinking Sound YouTube page, we've already posted a wonderful 8-minute overview of the application, how to move things around, where everything's located. And it's a good general app overview. So be sure to check that out. It is also on the front of the help website as well. And with that in mind, let's get started. So today's theme, as we said, is what is Spacemap Go? And so we're going to answer a couple questions. First, we're going to talk about what the Spacemap Go system is, what components are needed to make one. And then we are also going to talk about how to get connected very quickly. And then we're going to talk about the concept of what a space map is, which is the root of this new immersive mixing tool. So let's get started. What is Spacemap Go? Well, Spacemap Go is our new spatial sound design mixing tool that leverages the Galaxy processor. It's built on top of the Galaxy platform, so you can use any Galaxy, and the Spacemap Go application can run on top of the existing Galaxy infrastructure. Now, your Galaxy is a loudspeaker processor. You can still tune your system. You still have all of the filters and all of the awesome features that the Galaxy processor provides, things like low mid beat control, U-shape filters, EQ, everything that you've come to know and love with the Galaxy. But now with this free update, you can use Spacemap Go to control the summing matrix within the Galaxy. It's now this new immersive mixing tool that allows for very easy, simple, flexible, and scalable use. And it is controlled by the Spacemap Go iPad application. There are tons of applications for Spacemap Go. And the way I like to think about it is any place you have a Galaxy or using a Galaxy and have loudspeakers connected, you can actually utilize Spacemap Go. There's a lot of markets, as you see on the left, and use cases for Spacemap Go. But if you just have two channels, left and a right, you can actually still use Spacemap Go to pan sound left and right. And while surround sound and immersive formats and the fundamental physics of system design still apply, pick the right speaker, put it in the right place, and point it in the right direction. Those are rules of physics for any sound system you're going to design. While those still apply, and when you're building an immersive system, they're important. The beauty of Spacemap Go is that you can still build a space map to move sound to whatever output you want. Now, of course, the rules of physics apply. So if you want everyone to have an immersive experience, system design needs to take place. And for more information on system design, we are populating the help website as we speak. And with that in mind, let's talk about some advantages of Spacemap Go. First of all, my favorite is it's a complimentary upgrade to Galaxy. So if you own a Galaxy or if you're renting a Galaxy for your show, and Spacemap Go can be used in your system. All you need to do is download Compass, update the firmware on the Galaxy, and then download the free application. So it's completely complimentary. And we anticipate that this will be a widely used platform because there's so many galaxies out in the world. Any galaxy can be used for Spacemap Go. And while there are loudspeaker layout formats that are in the world, things like a 5.1 surround sound system, 7.1, Spacemap Go is really designed for a live environment. And so we can embrace the physical loudspeaker locations that some of these surround sound standards apply, but we're not beholden to them. A Spacemap can be used in any loudspeaker configuration. The limit is your imagination. Content is another thing that comes up a lot. And really, we like to say that Spacemap Go is content agnostic. So you can send us a main left and right console feed, just a stereo feed, and you can move sound around with Spacemap Go. Or you can have dedicated instruments, sound effects. Some people even do reverb, and they bust their favorite reverb plugin in and out. And not only is it for live environments, but it's also for theatrical environments. So sound effects and movement is a very big thing with Spacemap. So the world is your oyster, really, with as what you send into the galaxy, it can be moved around with the Spacemap Go application. So with that, it is a professional product. It is a galaxy, and we have implemented multiple levels of snapshot automation control, so you can program your system to work and implement smoothly into your existing workflows, whether that's a live or pre-programmed theatrical environment. Some other advantages that are very useful is Spacemap Go handles X, Y, and Z very easily. And one of the things that I love talking about is the fact that it runs on an iPad. It makes collaboration with the visual artists that we work with all of the time, people like the lighting designer, the director, the production manager. It's really easy to hand them an iPad and say, this is where the sound is going on the stage. And it's just a great visual tool for collaboration. Since the controller is run on the iPad, we also embrace some of the cool features that an iPad offers. Things like multi-gestural control, pinching, dragging, touching, tapping. And being that it's running on iOS, you can also save, share, and load all of these libraries of space maps and program everything offline. And you can text yourself a project file. So sharing and saving files is actually really cool within Spacemap Go. And it can run on multiple iPads, so you don't need to worry about losing battery from one iPad. And it's run also, all of the movement gets run on Galaxy. And we'll talk about that in a second about hardware. So a couple more advantages. With the Spacemap, it's very easy to base manage. And it's also very easy to deal with subsystems. If you have a fill in your system, whatever flavor of fill that is, delay fill, under balcony, over balcony, side fill, up fill, down fill, east, west fill, whatever type of fill it is, Spacemap Go has nodes that allow you to mix down subsystems and easily control very complex sound systems. And one of my favorite things is you can actually program your whole entire show before you walk into a venue. And this will save a lot of time and a lot of money. We've also implemented a very robust and easy to read open sound control solution. Open sound control is an Ethernet control protocol that's an open standard. And so we can easily integrate with all of the third-party apps that you might be used to. And now let's talk about what makes up a Spacemap Go system. So in the very basic sense, the Spacemap Go system, you need two things. You need a Galaxy and an iPad. And if you're tuning a sound system, chances are you'll have a computer with Compass. So a simple Spacemap Go system could be one Galaxy, and it doesn't matter what type of Galaxy you're using, whether it's an 816, a 408, or an 816 AES. Any of those galaxies can be used, and multiple galaxies can be combined. In order to combine the galaxies, you need an Avenue certified AVB switch. The Spacemap Go application automatically connects all of the galaxies, and we'll talk about that in a second. So those are the basic four components that you need. You need an iPad, a Galaxy, a computer for Compass, or you can also use Compass Go on an iPad, and then you need an Avenue certified switch. So we mentioned that you can use multiple iPads, and it is a client-server relationship. The client are the iPads, and the server is the Galaxy. So all of the actual movement and the processing is being handled by the Galaxy, and the iPad is merely a controller. So you can use hardlined or wireless networks for show critical environments. Of course, we recommend a hardlined iPad into your network switch, but it works well over Wi-Fi, and you can have multiple iPads and have different views and control different sections of your system. So this will allow for ultimate flexibility in theatrical as well as live environments. You can actually build a mixer out of multiple iPads, and it's really cool. And as we said, OSC is involved. Here's some of the things that we are integrating with. But basically, if your third-party device can speak OSC, if it can send and receive open sound control messages, you can speak to Spacemap Go, and you can speak to the Galaxy processor. We are working with RTTP-RM protocol. I think I got that right. And that's implemented in products such as Blacktracks. And we do work with most of the standard DAWs that you can use, any DAW of your choice, really. There's a plugin, and then there's also QLab integration as well. So if it speaks OSC, you can talk to it, and it's bidirectional control. So look at the help website for more information on that. And we'll actually be covering third-party control next roundtable. So how do you get connected? Well, very simply, once you've got your hardware, or even if you don't have hardware, it's a 5-step process. The first thing you're going to do is name your Galaxy processors. The next step, if you have more than one Galaxy that you want to act as a Spacemap Go system, you need to set a group name, and that group name needs to be the same. And then you need to reboot that Galaxy into Spacemap mode. So those 3 steps happen within the Compass application, and they're very simple. All you do is name your Galaxy, set a group name, and reboot it to Spacemap mode. And once you've done that, it'll appear within the iPad Spacemap Go application, and then you answer 2 questions. What type of inputs do I want to use, whether analog, AES, or Milan certified AVB, and how many do I want to use? All of those types of inputs can be intermixed. And after you answer those 2 questions, you save it to the system, and the application does the work for you in interconnecting everything. So here's this configuration in real time. What I have is 2 Galaxies in virtual. So I'm not connected to hardware. It's just virtual Galaxies. And all I do within Compass is add 2 virtual Galaxies. I name them, and I set their group name to be the same. And then I go into the Settings Network tab, and I reboot the Galaxies into Spacemap mode. And you'll notice within Compass, they turn green and then orange. And Compass is then, with this orange color, notifying you that something's a little bit different about these Galaxies. From there, if I'm on the same network, they'll automatically appear on my iPad. And then I decide what type of input am I going to use. And I also decide how many inputs I want to use from each Galaxy connected. In addition, you can also connect Milan certified AVB signals. In total, you can have up to 32 inputs with Spacemap Go. And we'll talk about that in the hardware section. So after I answer those 2 questions, I click Save to System, and the Spacemap Go application auto configures the Galaxies to work together. From there, I just go in to a channel that I want to control. I add a space map, whether I create one or use one of our pre-built templates that we have included in the app. And within a few minutes, I'm connected, up and running, and I can actually start moving sound around very, very quickly. So this is offline completely, what you're seeing here, but the same procedure would happen for hardware. Once again, here are those steps. Name your Galaxy, set a group name, reboot to Spacemap mode, select what type of inputs you're going to use and how many, and save it to the system. Now, one caveat is if you have an existing Galaxy system and that's been calibrated and tuned, and you are excited about Spacemap Go and you want to use that, there are a couple more steps that you will need to follow. And for more information on that, you can go to the help website under in-use processor. And basically what you need to do is save a Compass snapshot, load it in, and then reconfigure your inputs. So it's a couple more steps. The help guide does a very good job and a very detailed job about how to do this properly so that you have all of the settings that you need. And now let's talk about various hardware configurations. So people ask all the time, how many inputs and how many outputs can I use with Spacemap Go? Well, the most basic example system would be a one galaxy system. Here we have a single galaxy, and with that you could have 8 physical inputs and 16 physical outputs. And those inputs could be analog or AES. And also, since Galaxy is a Milan certified device, it can have up to 32 Milan certified AVB channels. So in total, every Spacemap Go system, as we said, can have 32 inputs. And those can be various inputs such as AES, analog, and Milan certified AVB. And they can be intermixed and mingled together. But once you add an Avenue certified AVB switch, for Milan, the world of possibility opens up. And if you have that switch, things can start getting really, really interesting. So here would be an example of a 32 by 16 channel Spacemap Go system. But since we have the switch, we can connect multiple galaxies now to the system. And with 4 galaxies now, I have a 32 by 64 channel system. And this can be expanded upon even further. Here's an example of a tested system with 8 galaxies. So we have a 32 by 128 output system. This would be very useful for something like a theater where you need to control multiple underbalks, you have multiple balconies of surrounds. And if you want to get even crazier, we've actually tested this and it's functioning. You can have up to 16 galaxies, so 32 inputs to 256 outputs. Since it's Milan certified AVB and it's redundant, you can have seamless failover and redundancy across a primary and a secondary network. So really your limitation is 32 inputs, but with Spacemap Go, I think you'll find as you start exploring the application and how to use Spacemap that 32 inputs is a lot of channels and 256 outputs. If you are used to our previous generation of digital products, things like Dimitri, this number of outputs is the equivalent to a DCM4 Dimitri system, which is a maxed out system. And it's really quite impressive. So the nice part about this compared to Dimitri is within 5 steps, I can still configure this amount of system in the same amount of time as we saw in that video. And so this allows for a very flexible and easy to control solution that's incredibly scalable. And in the coming roundtables, we'll talk about scalability, and each roundtable will cover a small, medium, and the last part roundtable will cover a large system. And since it's a Milan certified device, there's multiple ways to deal with galaxies. Things like festivals, where you have a galaxy that's dealing with line arrays. We'll talk about various approaches of how to deal with that as well. So the scalability of Spacemap Go is really quite incredible. We're really excited to see what you guys do with it. And with that in mind, we'll talk about what Spacemap Go is actually controlling. Well, Spacemap Go controls the summing matrix within a galaxy. What we see here is as I move the iPad app around on the right, you can see that the summing matrix of this channel, which would be channel A of this galaxy, the summing matrix is being easily manipulated. And you'll notice on the right that there are blue dots, and those blue dots are what we're calling nodes. And we'll talk about that in a second, but you'll notice a white halo that moves up and down around them. And this is a visual layout showing you the level of the summing matrix for that specific cross point within the matrix. So not only do you see the matrix cross point up top and in compass, but you also now have a white SPL sort of halo indicator for each output cross point within your Spacemap Go system. And that just expands further. So all 32 channels represent 32 matrix rows within the galaxy. Since a galaxy hardware device can have 32 inputs or 32 matrix rows, that is why we have a 32 channel limitation. And as we see that each one of these channels is independently manipulated. And so this allows for static feeds to be set up as well as dynamic feeds. And you can also have trajectories trajectories, which we'll talk about, but trajectories are predetermined pathways for sound to travel. And you can, in real time, select a trajectory, start playing it and moving it around. And since we're on an iPad, you can actually drag and drop and pinch and rotate the trajectory. And in real time, you can manipulate it. And this allows for a lot of flexibility within the Spacemap Go system. Spacemap Go controls the summing matrix of the galaxy. And now we'll talk about what is a space map. Well, a space map is a visual representation of a loudspeaker layout. These are 2 examples of space maps. Even further, we have 4 more examples of space maps. And so in talking about space map, it's important to understand how this is actually working. So a space map is a visual representation of a loudspeaker layout. It doesn't have to be the actual representation of a loudspeaker layout. What I mean by that is on the top left picture, you see a standard 5.1 loudspeaker configuration where you have 3, a left, center, right speaker, and then you have 2 rear speakers, and then you have a subwoofer. And in most cases, that loudspeaker configuration, if I were to move the sound to the top left corner, move my locator to the top left corner, the sound would come out of that speaker on the left that I point to. Well, that's great and that's very useful, but sometimes you don't need that. Sometimes you want to just design a map, a space map of where you want the sound to go. And on the top right-hand side, here's another example. This would be a sort of an example of a restaurant system where you have 16 loudspeakers overhead, and you can easily design this overhead system and use your finger to move sound throughout the space. And on the bottom left, one of the buzzwords right now in immersive audio is frontal or collinear systems, where you have multiple sets of speakers across a single plane. Well, you can easily implement this and design that within Spacemap Go. Really, the limitation is how you design the map. And that is an example of a 5-speaker frontal system, where as you move up and down the map, it controls the stereo width of a linear frontal system. And on the lower right-hand side, Spacemap got its start. It's been around for 20 years, and we've had different implementations of it. But Spacemap, in a lot of Cirque du Soleil shows, has been used. And so this would be typical of a tent. And it's like 12 speakers, and it's a very circular tent sort of picture. But we'll use that example of the 12 loudspeakers and talk about the physical layout of the loudspeakers versus the physical layout drawn as a space map. And what you see here is the 12 loudspeakers represented. As the panning locator moves along the space, we'll notice that the audio energy follows in linear order. And just in case you missed it, we'll play that again. So here we go. Here's our 12 loudspeakers. And here is a space map representing those loudspeaker locations. And as we see here, it's physically moving around and associated with the location of the loudspeaker. Well, as we said, a space map is an abstraction. And so you can actually program space maps to not represent the location of the loudspeaker. Here's that same map programmed differently, and we'll notice that the audio energy is energizing random speakers within the ring of speakers within our circus tent. And so this is one example, and we'll talk a little bit more about that as we talk about what makes up a space map. There's some components of making a space map that you need to understand before we get into building a space map. And so within the Create library, within the application, there is an entire list of pre-built templates that you can use and modify, but you can also create your own space map, which we'll do in a few minutes. And we'll talk about what makes a space map first, and then we'll start building them. So there are different components of a space map. In order to build a space map, you need nodes and you need trisets. Nodes represent various things, and trisets represent the panning surface. And so right now we'll talk about trisets, and then we'll move on to nodes. So fundamental to the space map algorithm is the idea of a triset. It's a 3-point panning surface. So if you imagine a pan pot on a mix console, when you move left and when you move right, that is a one-dimensional move. Well, when we're in this sort of top-down plan view, you need a third dimension to understand the relative level between each point. It's triangulation. We've developed a mathematical algorithm that allows for equal power panning amongst the triset. A panning surface is composed of multiple trisets. So a space map is composed of multiple trisets. And down below, what you have is a single triset composed of two loudspeakers, a left and a right. And then we're using a third node to complete the triset called a virtual node. And that virtual node is not connected to a loudspeaker. It's just completing the triangle. It's completing the third point. And you'll notice as we move left and as we move right that the halo and the matrix levels correspond. And as we get closer to the output or the speaker node, the level gets larger. And as we move away from it, it shrinks. And that is also represented in the matrix. So trisets are your canvas. In order to have a space map, you need to build your canvas from trisets. So in order to make trisets, you need to have 3 points. And those 3 points are composed of nodes. So there's 4 different types of nodes. And the first type of node we'll talk about is the very simplest node. It's a speaker node. A speaker node represents an output. And within the create window of the space map, you can actually click the ... which is what you see on the top left, and you can actually assign what output you want to use within the system. And so you can easily add multiple outputs, and you can make a logical layout to represent the loudspeaker locations of your room. And that's what you see on the bottom left. There are, of course, no trisets in that square that you see of speaker nodes, but a speaker node is an output. And you can also create abstract layouts. So if you need to move sound in a very specific way around the room, or if you need it to hit multiple speakers at once, there are ways to do that. So we have a visual representation on the left and an abstract representation on the right. Our next node is a virtual node. And a virtual node is sort of our multi-use node. It's a jack of all trades node, and it serves a couple purposes within our Spacemap Go system. The first part, as we discussed when we were talking about trisets, is a virtual node can be the third point connecting a triset. So it can be an anchor point for a triset. And if you need a panning surface, if you need a triset and you're missing a part of a triangle and you don't have a speaker node there, you can simply add a virtual node and it will complete the triangle for you. Or a virtual node can also provide weighted power distribution to multiple speakers. The example you see down below, what we've done is we've linked the virtual node to the 2 speaker nodes. And now within the triset, the relative weighted relationship, or the SPL level of the cross point within the matrix, is now weighted towards each other. I know that sounds a little confusing, but to make that make sense, let's think about a wall of speakers. So imagine you had a wall of speakers on your side. And let's say you have a sound that you need to be 85 dB within the room. Well, you can have a virtual node and connect all of those wall of speakers to that virtual node and then build a triset. The Spacemap Go application will divide the weight, or the SPL level, of the virtual node amongst the speaker nodes that are connected to it. So let's say I have 4 outputs and they're connected to what you see there is 1 virtual node. The Spacemap Go application allows the virtual node to evenly mathematically divide the power amongst those 4 nodes. So this is very useful when controlling multiple speakers. If you need a wall of speakers to get the same sound, but you don't want the levels to be incredibly large and absolute, you can control that via a virtual node. And the weighting can also be adjusted per output that you assign to it. So each individual speaker you can decide with the percentage amount that each speaker will receive. I know that sounds a little confusing, and to make it even more confusing, on the bottom, what you have is a picture of a randomizer virtual node map. And it's important to note that speaker nodes can be connected to any number of virtual nodes. So this allows for ultimate flexibility. And what that actual space map that you see there was just implemented in a football stadium for audience replication. And what we did was use this randomizer map for a mono signal audience source. So the crowd noise was a mono signal. And we use this map and another map and mix between them to create random energy adjustments of a 16 channel, large stadium system. So with the touch of a finger, we were actually controlling a whole entire stadium. The cool report from that was that on game day, the audio guys within the stadium said it sounded like game day. So we had a mono signal that we were forced to use. And with the power of Spacemap, we created this very lush and immersive mix. And that's the power of a virtual node. And here's a couple examples to really bring home the point. So here we have 9 speakers connected to 3 virtual nodes. And it's important to note in this example, we have the trisets are only connected to the virtual nodes. So as I move my finger across to each set of nodes, we'll notice that the audio energy expands and contracts, and we're evenly weighted and distributing to the 3 speakers that are connected to it. The next use of a virtual node, as we said, is speaker nodes can be connected to multiple virtual nodes. So this is a space map that we like to make called an additive space map. And what it is as I move my finger left and right, we have traditional stereo panning, but as I move down, we start adding audio energy to multiple speakers. So in a very quick, with the move of a finger, I can now have the audio distributed amongst a large amount of speakers. So this map was actually also used at the stadium and allowed the marching band recordings to move up and down the field quite quickly. And they could also delineate between the home team versus the visiting team side of the field. And so this allows for complete control, and a speaker node can be connected to any number of virtual nodes. And this is where the power of Spacemap Go is we're no longer limited by the physical location of the loudspeakers. It's really up to you as the designer, the sound engineer, to decide how you want the sound to move. And all you do is create a space map that allows you to do that. Our next node is a silent node, and it's very simple. A silent node sounds exactly like what it is. Here's that same 2-channel stereo left and right space map with 1 triset. And we'll notice that as we move up, the audio energy, as we get closer to the speaker nodes, increases, and as we move back, the audio energy decreases. So a silent node allows you to do fades. It's a level control for the cross points. Here is an example of a 5.1 sound system. And what we have is a boundary of silent nodes. So this is very useful for live environments where you want sounds to fade in and out, or theatrical environments. And now, instead of having to touch a console fader and move the level as I move the sound across, I can just build a space map that has the fades and allows me to fade in and out of the map. It allows for flexibility, and silent nodes can be used in a lot of different ways. And the last type of node is a derived node. And a derived node is sort of the exact opposite of a virtual node. If you use your context clues, a derived node derives its audio signal from the speaker nodes that it is linked to. And this is another multi-purpose node. It can be used for things like subwoofers and easy bass management, but it can also be used to control fill systems as well. And it's important to note that it's very opposite of a virtual node. A virtual node sends to multiple speakers. A derived node receives its audio from multiple speakers. So you can think of a derived node sort of like an aux send on a console. It's very useful for a lot of applications, and we'll talk about 2 of them. The first application of a derived node, as we said, is a subwoofer. So here we have a space map with 4 channels or 4 speaker nodes and a virtual node in the center. And all I do is add a single derived node, and then I can, within the application, link the subwoofer to the 4 speakers. So now, anytime any one of these 4 speakers receives audio information, it also will send to the subwoofer. So this is how you can create full range audio. Let's say you have a wall of subwoofer, or you have subwoofers on each wall. You can then link to that subwoofer, and it allows for full range audio and movement throughout the whole entire space. So that's one use. It allows you to easily bass manage full range content. But the other use, and what I think is a very fun and interesting use, is to use a derived node for subsystems. So in this example, we have a space map that consists of only two speaker nodes, a main left and a right speaker node. And then we have multiple derived nodes. First, we have some front fills. So we'll notice that these first two front fills are connected back to the main left node. Then we have two on the right. And then we also have outfills or side fills, as they're commonly called, connected to the mains. And so now when we move around on the triset, we'll notice that the audio energy arrives at the front fills, the side fills, and the mains, and they're all equal level. And you can actually adjust or trim out each one of these nodes to decide how much audio level you want, or you could just adjust that within Compass on the output processing as well. A derived node allows a lot of flexibility. Now we're going to talk about just like making a space map very quickly. But before we get started, just to hit home the point, we have a selection of outputs here. And here's our summing matrix within the galaxy. And these channels that you see within the Spacemap Go application represent matrix rows. I'm going to just add quickly one of our pre-built space maps. And if we sort by ID and ascending within the application, here's the library of pre-built maps. And we'll see various different versions of loudspeaker configurations of most of the standard immersive audio formats that you are used to. And as we move down, the space maps get a little more complex. And here we have examples such as this collinear system, which would be 5 speakers up front and 6 surrounds. And just for an example, I'm going to add that, and then I'm going to start grabbing, and we'll notice that the cross point matrix of this first channel moves around. And if I were to go here and add another map, a different space map, we can see here that the second round of Compass, the matrix, is moving around. And if I click into the channel, we can also see that this is represented via the matrix up top and via the blue halos that we see around each speaker node. And so it's important to note that each channel on the Spacemap Go system, and as we said, we can have up to 32, each channel can have independent space maps. So you're not limited to one space map for all 32 channels. In fact, every single channel can have 2 space maps. And what that is useful for is dealing with the vertical plane. In one example, we'll sort by date created. In one example, we'll talk about dealing with vertical speakers versus lateral surround speakers. You can deal with that a couple ways. One way is to just design a space map. Here we are. Here's the space map to where I have a left, a right, and 2 surrounds on my back wall. And then I have 4 overhead speakers. So if I were to move sound around, we would notice that it would fade in and out. And that's one way to deal with the vertical and horizontal. But another way to deal with it is to actually build 2 different maps. And we can use first a map like this, which would be our surround laterals. Then we can also have a vertical map. And this would be our overhead system as well. And we can actually decide how much energy we want to use between each one. So we can crossfade between the 2 maps. So that way, and forgive me, I'm going to use my fingers for this. So as I move across, I can easily mix how much I want in the overhead system versus how much I want in the side laterals. And so this allows for different control. And I'm going to keep the position there. And we'll notice as I'm on the map that is for the vertical system, we'll notice that there's audio energy within the matrix. And then as I crossfade to the laterals, we'll then notice that now the audio information is distributed amongst the matrix in just the laterals. And if I want to tease in the overheads, I can easily just touch the crossfade and decide how much energy I want to distribute amongst them. So that's a useful feature. And I know that might be a little confusing, but play with it, experiment with it. And now let's talk about making a space map. And so here we go. We'll talk about space maps first. And what I've done here is I've basically taken our space map from our galaxy. all I did was label our galaxy channels. And we'll notice now that each one, I added a whole bunch of nodes, and each node is representing an output on the galaxy. If I wanted to do this from scratch, I'll click cancel. All I would do is click create new. And when you're planning your system, it's important to plan where your outputs are because it lays out very easily. So here we go. We'll just add our main left. So I'm going to click here, and Spacemap Go automatically assumes that it's the first channel in the system. So main left, X40, output 1. And I click here. Here's my main right. And I could do this and keep this going. And since I know I have this many speakers, I've arranged my outputs to lay out this way. And so this allows for a very simple configuration. And I know my overheads are in these channels in a linear order. And then next thing, I know I have some subwoofers in the system. So I'll just add some derived nodes. We have one here, which is our main sub. And I know I'll have one here, which is the left sub. So what I'll do is I'll actually just hold down my finger and touch hard. If I don't want it on the map, I'll hold down my finger and then I can drag it to where I want it to be. In this example, this is a visual representation of the space. So I want my left sub to be on my left wall. And then all I'll do simply is add another sub, and we'll put it right here. That's the right sub, and here is the rear sub. And now we have all of our outputs of our galaxy represented. We can see them here. They are also represented in this space map. And we can now, just for simplicity, add a virtual node. And here's where we would build our trisets. And we can add a triset by simply connecting 3 points. So I can click on each node and we can build a triset panning surface. And we can make it look like that. Or what we can do now is auto build trisets. And this makes our job really easy. We can have the Spacemap Go application build the triangles for us. And we decide what type of nodes we want to connect the trisets to. You cannot connect a triset to a derived node because it's used for a subsystem. So we'll just say build trisets, and Spacemap Go will make trisets for you. There would be some things I would need to do. If I want this whole map to expand across the whole playing surface, I would just touch and drag and then manipulate each one of them independently. Let's see. And I could spread it out. But for the sake of this, here's an example. And then I can go to the test button here. And now I can see the matrix levels and see how the audio is being manipulated. The cross points of the matrix are being manipulated. And if I need to do any changes or anything like that. And one thing I forgot to do was connect my subwoofers and tell them where they're getting their energy or their audio information from. So very simply, I can just click my first sub. I click link speaker. And if I want to, I just link that output to those subs. And we have 4 subwoofers in this design. So I will decide that the closest speakers to each subwoofer, those are the ones that would get linked. And so here we go. I'm linking this sub. And here we go. And one last one. I'm linking here, 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 and here. And you can see how quick this is. I mean, this is not an elegant looking map at all. And you would need cleanup. And I like to have my maps to where the whole panning surface is used. So I would click and drag nodes over to get them to I would click and drag nodes over to get them to work and move over to the wall.
Hey, Josh,
for some reason.
what
Yeah.
if you don't have the whole space map covered by trisets?
Oh, if you don't have the whole space map covered by trisets, you'll notice that as I move audio, the matrix is moving nice and pretty. And then as soon as I get to the edge, you'll notice that the matrix completely drops out. It will just disappear. So the triset is your canvas for moving, panning around. Now, one way I could deal with this is add some silent nodes. And so we'll quickly just add a few silent nodes here, here, maybe here, here, and here. Why not here? Why not here? And then what we'll do quickly is take our try set, we'll delete all of them, and then we'll say, hey, Spacemap Go, remake this for us. And here we are. Oh, I missed that guy, so I'll just drag it over the corner. And now if we click test, we'll notice that we have a full panning surface, but as I get closer to the silent nodes, we'll notice how elegant and nice that fade out is, as opposed to just dropping off the edge of the world. That is basically how you make a space map, and you can play around with it. Once you're done with it, once you're done making a space map, you can easily name it. So we'll name this doesn't look that great. If we wanted to, I think we can add emojis. Yeah, so there we go. And we can then, once it's been named, we can exit out of it. Oh, I forgot to press return. So we'll just make it a couple emojis and press return. And there we go. We click done. And there we can see our space map is now appearing in our space map library. And if I want to, I can easily just select it and put it on any channel I desire. And there is our emoji space map. And here it is. And it can move around and be used on any one of these channels. So one last thing that I would love to talk about before we get going for questions is trajectories. And trajectories are pre-built pathways. So in a simple form, a trajectory can move sound around. And you'll notice here, as I click touch, I can now move the sound around and have the different pathways work. I'm just adding random maps. And so now here we go, and I can speed it up and I can manipulate it and pinch and drag. And one thing about trajectories is you can create them quite simply, and you can also import them. Within the create window here, I have trajectories that I've pre-built. One of my favorites that I just made is the Soundosaurus Rex. And if I want to, I can easily go into this channel. I can add my custom Soundosaurus Rex that I drew by myself. And now my pathway is actually the drawing of the Soundosaurus Rex. And I can pinch and I can drag and I can make him walk up. And in real time, it's still manipulating the audio, but this pathway is being set. And so we'll build a trajectory real quick, and then we'll open it up for questions. So all you need to do to create a trajectory is go to create and then hit this trajectory tab here. That opens up the trajectory library, but all you need to do is click create a new trajectory. And all you need to do simply to create a trajectory is click start recording and then just tap. So if I need a sound to go there, 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 and there, I can have it do that, but I can also touch and hold down my finger and have it move like that. There's also some settings for if I want it to snap to the grid or not. And just for simplicity, we'll re-record this and make it a quick little square. We'll click record. Okay, and now we have our nice little movement like this. And what you can do within the trajectory editor is actually build in wait times of movement. So let's say when I get to this position on this map right here, I want it to pause for 3 seconds. Well, all I do is add a wait time right here of 3 seconds. And now if I play back my trajectory, we'll notice that the sound will pause there for 3 seconds and then move down and continue on its loop. That's very useful. Let's say we need this movement to actually be a specific amount of time. Let's say you have a sound that's a drum or a sound effect that needs to rotate around your pathway for a total of 10 seconds. Well, all I need to do is adjust the total duration of that trajectory. And I'll actually take out the wait time here, and I'll adjust this to 10 seconds. And now we'll notice that the overall movement of this trajectory will take exactly 10 seconds. And so Spacemap Go divides all of these points up and does the math to manipulate the pathways for you. From there, I can easily name my trajectory, and I can also save it. And as soon as I save it, it'll pop up a window and ask me to save. Well, it's not going to do it there, but if I want to, and when I'm offline, I can actually decide what space maps I want to use that I've created, and I can actually save them as trajectory files. It'll come up on the iPad. I could text this file to myself. I could airdrop it to my computer. Also, I could save it locally on my iPad. And that's how things get saved within Spacemap. So let's get into talking about the application. What questions do you have? Let's open it up.
Here's one from the crowd. Charles asks, can trajectory span multiple space maps?
To add elevation, you can add a space map to a single channel. So here we go. Here is a movement where we have one trajectory playing. And with the use of multiple space maps to span elevation, we can see that that trajectory can be involved and mixed amongst these. Now, visually, the map disappears, but we can see by the percentage sign that the audio levels are actually still being manipulated. The cross points are still being manipulated. So yes, this trajectory can span multiple movements. A very simple example of that would be...
You can watch your output levels at the top there.
Yeah, exactly.
The speakers on the ceiling, you can just watch those outputs and see level come and go.
Yeah, and
between the two space maps.
Yeah, and so here we have, let me just load this was our overhead, this was our overhead space map. And then this was our lateral space map. And so I have the lateral is actually now on the right. So we see as I move it completely over perfectly, we see that the matrix levels is just hitting the lateral speakers. And as I move it over to the left now, we see that and I got to be right on it. That's 100%. So now we see that the level is there. And as I slowly mix in, we can see the level crossfading between the two. So then all I would do is add a trajectory. We'll make a very simple trajectory. I'll pinch it and drag it. And let's say I wanted to go across the theater. We'll start out in the laterals and we'll make it slow. I'm adjusting this. And then as it moves across, I can simply fade in how much I want it to be in the overheads completely and crossfade it back into the laterals. So that's how you deal with the vertical plane one way. The other option would be to have a space map built like this one. Here we go. I'm gonna move it over here to where the overhead speakers are actually programmed within the space map. And so now as we move, I'm gonna speed this up a little bit. You can deal with it in multiple ways. We don't want to limit you. And also with tracking systems like BlackTracks, you can actually program the crossfade to be the Z axis within BlackTracks. We won't talk about that in the roundtables, but you can actually program this guy over OSC to manipulate how much height you want to add. So if you have two maps, one for lateral and one for overhead, you can easily use the tracker to move it up and down. Yes, yeah. If you want the helicopter to fly through the air, or one of my favorite ones that a space map was ever used for was a tornado and the sound of a cow. And it started out with in the lateral speakers and the tornado. And we actually have a sort of, here's a spiral.
Were you the designer on that one?
What's up?
Were you the designer on that one?
No. It was one of my colleagues. And then you can actually just move it up to the overhead speakers. And now the cow is all the way up in the air and it needs to go back down. And if we want to speed up the tornado, we can easily do that. So this allows for complete flexibility and control. And or let's say I'm live and I just want to figure out where I want the sound to go. I can touch it. And I'm touching the iPad with my finger and replicating what I want. And then I could just build a trajectory to do that. So it gives you a lot of options. Yeah, how do you control the source width of a sound? Charles, what do you mean by that?
Have you talked about the spread option?
Oh, we haven't. Let me just load a very simple map. So again, we have a library, Spacemap. I sort by ID and ascending, and we have very simple maps up front. So we'll just do this with a quad, a 4.1 system, and I'll fade it all the way over. So now, and I'll get rid of our spiral. And now we have a quad system. So a virtual node can do it, where you see the audio energy as I get close to the virtual node. I'll just grab it with my mouse. The audio energy spreads out. But also with each channel, on the mix view, as well as in with the channel view, you have a spread feature. And a spread feature is a percentage of how much spread you want. So let me go into the channel view. It's also in the channel view down here. So we'll notice if we look at the matrix, let me just put the sound in the corner. We'll notice that we have very low levels for most of our speakers and our subwoofers getting it. But as I add spread, just look at the matrix. We'll notice that now the spread, when I get to 100%, is, well, we said 6 dB down on the subs, but everything else is 6 dB. That's what spread does. It spreads the energy. So if you want this audio piece of information to be a little bit wider, you can actually implement a little bit of spread. And this is a logarithmic fader. So 50% is actually around 10%. And we found that around 10 to 15% adds a very nice width. So when you get halfway, your width is very nice, as they say. And if you want more and want it everywhere, you can just easily spread it that way. So Seth asked a question, which is, can summing nodes feed other summing nodes? Say you have multiple 900 LFC and one VLFC. Well, there's a couple ways you can do that. If I create a Spacemap here, where I have just a main left and a main right, and I'm going to just add a virtual node and make a single triset to connect the two. So there we go. I can add as many virtual nodes as I want. And ignore the labels here, but if we change these labels to be 900 and VLFC, all I need to do is link to each node. Now, a derived node cannot arrive at another derived node. So I think that's what you're talking about, which is the derived nodes. A derived node can't connect to another derived node. So you can't have a subsystem. A derived node is really just for a subsystem. And one way to deal with this, if you have multiple galaxies, is actually just use one galaxy and put it in Spacemap mode and have this output. I'm going to go to Compass real quick. Let's say this was your feed to normal galaxy. So let's say you had a normal mode galaxy, and what you could do is program that normal mode galaxy to receive output 16 from the Spacemap galaxy. And so anytime output 16 within Spacemap got fed via the Spacemap module, it would then send to this galaxy and feed various speakers. And we'll talk about this in large scale systems on Roundtable 4, but this allows one Spacemap galaxy to control a plethora of galaxies over Milan AVB. Each galaxy can use Milan. And so all you would simply do is connect that other galaxy. I'm not on hardware right now, but all you would simply do is connect that galaxy here to the Spacemap galaxy. And that allows for a lot of interesting functionality. So you can use one galaxy to control a lot of PA. Are there any plans to eventually have a desktop Spacemap Go app? Yes, absolutely, they are. We do realize that that is a thing. Before we design a Spacemap desktop app, before we do that, we want to get a little bit more feedback and feature requests on the iPad application. And it's important to note, I'm using an app called Reflector. Reflector turns your iPad into an Apple TV. So I'm displaying it here. Play around with it, but we do realize that that is one thing that people need, and we are working on it. I can't tell you when. Can trajectories record the change of two space maps in one channel? No, but a snapshot can. What you can do, we'll just use channel 1 here. Yeah, this is going to go into Roundtable 2, but we'll just talk about it real quick. First, I need to make a mix snapshot, which we'll talk about next week. a mix snapshot takes a picture of all 32 channels within Spacemap. So we'll say top of show. And there we go. That captures everything.
And you got a 10-second transition.
Oh, yeah. And so a mix snapshot can also have transition times. And I'll just make it 0. So a transition time is how long it takes to get from one position to another. And then let's say in this channel right here, let me touch the top. Let's say in this channel, we want the map to go all the way over here, and we want it to move the location to move right here. All I'd simply do is click capture snapshot, and I can say move here, and I can decide how long I want that to happen. So something like 8 seconds. I can also just say when this gets recalled, wait a couple seconds. But in this case, with a transition time, in this case with transition time of 8 seconds, we'll do that. And now when I recall my top of show, we'll notice that the position of this channel is here. And when I recall move here, we'll notice that it's taking 8 seconds to move that channel across the board. So this gets very fun and very interesting, and we'll talk about this a lot more next week. And that allows you to do very, very fun things. Can you quickly show assigning a speaker node to a physical output? Oh yeah. All we need to do is click the ... and click set output. And what pops up is this list. And the green says, I'm already in use on the space map. But if I want to, I can easily just click what output I want to use. So we understand that you might not have all of your outputs in linear order, or you could move into a system to where you have a space map for one room that is a certain output, and you move into a different room and it's a completely different output configuration. So that's how you do that. In addition, for derived nodes, you can do the same thing and click set output, and it's right there. And then we talked about virtual nodes. So with virtual nodes, if you click the ... it gives you an option to distribute link weights evenly, but I can also click this, and I can actually distribute how much audio weighting I want for each node. So in this case, we'll say I only want 10% for that guy. And we'll notice that Spacemap Go divides up the 100% amongst the 4 in a different way. And it actually tells you how much level difference there will be amongst those nodes. And now anytime I test, we'll notice that one of these nodes is going to be a bit hotter or lower than the other. Yes, as you get more galaxies, they do just keep adding to that list. And within the application settings, you can see all of your outputs. I only have one galaxy connected. They would just appear as outputs here. And then within Compass, it's the order that you assign them. And all of those outputs lay out within Compass as you would expect them with different tabs. In terms of input signals, can AVB analog inputs be used simultaneously in a single galaxy? For instance, 8 analog inputs and some AVB inputs? Yes. So one important note about AVB is Galaxy is certified to work with Milan certified AVB. There are a lot of AVB products out there that are not actually Milan certified. Things that are Milan certified, you can go to the avenue.org website, and there's a list of certified devices that can interconnect with the Galaxy. Now, there are more products coming online, and there's a lot of options, but we can't guarantee that non-certified AVB will work. You're more than welcome to try it, but we can't guarantee it because we've rigorously tested and spent a lot of research and development with the Avenue Alliance on making sure our products interwork with anyone in the Avenue Alliance and the Milan paradigm. And so how you do that very quickly is you would go to Virtual Space Map, and it would ask you some questions. And if you're in an existing system like I am now, all you would do is click Inputs, and you'll notice that there's a couple options to connect AVB, but you can also click Reconfigure Inputs right here, and the device will appear. And here's my galaxy. I can decide if I want to use analog or AES and how many. So if I want to use 6, and you'll notice down below that it says you have a total of 6 physical inputs and 26 AVB inputs. And so you can click that, click proceed, and now it asks you if you want to add some Milan certified AVB inputs, and you click yes. And now we'll notice that my Spacemap Go system input amount changes to 26. Yeah, there we go. So it appears here, and now we have all 26. I think I had some other number in or something. But anyway, it appears here. In a non-Spacemap system, can you also have 32 AVB inputs? I honestly didn't know a galaxy could do more than 8 inputs before tonight. Well, yes, absolutely. So you have a normal mode galaxy. It's a little hard to find, but you absolutely can. If you go to settings and then in the input outputs window, there's a very small tab right here that allows you to have up to 32 inputs on a matrix over AVB. So these are actually AVB cross points, and those are then displayed in the summing matrix here. So here's my physical, and when I move down, here's my AVB. And the beauty of the Spacemap Go app is if you have multiple galaxies, the application does all of the AVB inner matrix connections for you. There's a very cool but intricate graphic that Steve has worked on that's on the help website that you can look at to see how things are actually interconnected. And when you look at it, and then you think about the 5 steps that it takes to configure a system, you'll be quite amazed at how cool it is.
Is it possible to have more than 2 space maps per channel?
At the moment, no, but if you design your space maps right and you think about this, and the way to think about a space map when you're building it is, how do I want my sound to move? So a lot of times you'll build a space map that is a general loudspeaker layout that represents the location. And then you can build multiple other space maps that do various things. And so think about it when you're programming your space maps. And there's a world of possibility. We're going to talk about artistic mixing and these sort of artistic decisions on the 4th roundtable. It'll be very exciting. And one other thing I want to talk about, guys, that I make sure we get in is a question about static versus dynamic. So what if I have a system and my console left is feeding here and console right and sub? What if I need them to just hit the outputs that they're assigned to? So anytime I send out of my console left, I want it to go to my main left. And anytime I send out of my console right, I want it to go to the main right. And anytime I go to my sub from my console, I just want it to hit my sub. Well, how do I prevent Spacemap Go, since Spacemap Go is controlling the matrix, how do I prevent these channels from being used? Well, it's very simple and it's client-based. So every iPad that you have connected can be set up to control it differently. So first thing I would do is lock out these channels. In the application, I can lock the static feeds of these channels to where I don't have to use them. So all I need to do is go to settings and then locking control. And there's a couple options to lock things out per iPad. I could lock out all the solo buttons and mute buttons. So if I'm mixing in a live environment, I don't want to hit this button and then my whole mix disappears. But if I'm in a show programming environment and I know I have static feeds connected to my galaxy, all I need to do is select what inputs or Spacemap Go channels I don't want the application to manipulate. I would lock out these first 3 channels. I click done, and then I enable it. And now on this iPad, I cannot touch the channel. So we can see that I can't manipulate the matrix within the application, but the unlock channel on channel 4, I can easily add a space map and move it around, and it's moving there. So this is how you create static feeds when you're programming, and it's client-based. So every iPad will have to be set up, if you're using multiple iPads, to lock out the channel. And that's a very useful feature. I can say that we are working on tap tempo. We'll be able to program it beats per minute. We're betaing it right now. We don't know when that will be out. So currently you cannot, but it is going to be implemented very, very soon. For now, program it in a third-party controller and very soon, or you can also use a calculator to calculate time to BPM for whatever time signature you're using, and then just make your trajectory that long. And that's one way to get around it. Depends on, of course, how sample synchronous that audio source needs to be.
And the trajectories can be synced by simply just recalling either a mix snapshot or a channel snapshot.
Yeah, totally.
Question here, can space maps be selected or changed via OSC?
The maps cannot be, but with OSC, you could recall the mix snapshots or channel snapshots, and that space map for that channel gets captured in there. So you could just have a different snapshot that recalls a different space map, and it'll work. We have some more roundtables coming up. We have Roundtable 2. Next week, we're going to talk about how to build a mix and then saving your work. And we'll do a very simple example with a system that you might have at your house, which is a 5.1 system. And then we'll get into third-party programming, and we'll program QLab to recall what we captured. So next week's all about saving your work, how to deal with it. And then week 3, we're going to take a medium-sized system and talk about dealing with subsystems, things like line arrays, front fills, side fills. And then Roundtable 4, we're going to, for the first part, talk about scaling Spacemap Go to very large systems, things like Metallica, where we have 23 galaxies in the system, and music festivals and stuff like that. And the next half of that roundtable, Roundtable 4, will be an artistic discussion with Steve Ellison, the man who created Space Maps. It will get into the artistic side of mixing and talk about concepts. So we're really excited to see what you guys create with this. On the Meyer Sound user community on Facebook, feel free to post your creation. We also have the Meyer Sound forums, which are on the Spacemap Go product page. And we can't wait to see all of the crazy and awesome and amazing sonic environments that you create with us. So with that, I'm going to wrap it up. Do you have any more things?
I think that's it. Just appreciation for you guys taking the time to visit with us and find out more about Spacemap Go. Look forward to seeing you next week. Take care, everybody. Bye-bye.
Bye.